Okay, continuing a little bit with the regression, we saw that we were able to get a regression equation for this data, and actually I think it was about, we had an r squared of about 80.83, which is pretty good, but looking at the picture suggests that it might be better to use some kind of curve to fit to this data. So how can we do that in Excel? Let me show you a way to do that. So suppose I want to generate a regression equation that looks like y equals like ax plus bx squared. How do I do squared here? I'll just put a 2 there, but I mean squared, plus c. So an equation like that. Suppose I want to be able to get an equation like that. How can I do that in Excel? In other words, I want to have an x squared term in the equation. So you can do that rather easily. Let me see. I think I need to insert a line here. Oh well, I didn't mean to put it there, but I can put it there. So what I'll do here is I'll write equals this one times itself. That will give me x squared, like that. Okay, and then copy that down like that, and let's call this F2 or something, fertilizer 2. And I'll call this, okay, just leave it like that. And now I can do the same kind of thing that we did before. So the only difference is for the input, I want to have both columns, column A and column B here. So that's why I wanted to put them next to each other, because you need to do that to make it easy. So if I go to data and data analysis and regression, and I want what? For my y, for my y I want here to here. And for x, I want to include both. So this one and that one. Both of them. Like that. And that's all you have to do. Let's see. Should be okay. Click OK. And there is the results, I hope. Yeah. And let me make this bigger first of all. And change the type of graph to a scatter plot. And let's see what the red dots do this time. Okay. So now you can see that I've my regression line is actually a curve, and hopefully it fits the data even better than before. And yeah, now r squared is up to 0.95, so it's much better than it was before. I think it was 0.83 before. So we have a much better predictor of yield based on fertilizer as compared to before. And in terms of the equations, you get the equation. I'm sorry. In terms of the equation, you get that from here. The intercept is 10 approximately. The x squared coefficient is 1.69 times 10 to the minus fifth. It's not so significant. And the fertilizer is minus 0.009. Okay? So, and we can also look at the confidence intervals for these coefficients. But anyway, that will give you the equation. and then you can use it. So what I'm saying, just to be clear about this, is the equation is something like this. Y equals approximately 10 for the intercept plus, I'll just say whatever, what is that, 0.00 something 00, I don't know if this is exactly right, 16 or something like that. I might not have enough zeros there. This is x squared. I'll just write x2, but plus, or actually minus, but I'll write minus 0.0096 approximately x. Okay, so that's the equation, and you can use that to take as input as the x variable fertilizer and get a prediction for the yield. Okay? Okay, that's all.